Good evening, everyone. So in today's topic, we discuss about different types of microcontrollers. Okay, the first type of microcontroller was 8051. So 8051 microcontroller is designed by Intel in 1981. It is a 8-bit microcontroller. It has 40 pins. So and 4 KB of ROM storage and 128 bytes of RAM. 2 and 16-bit timers are present in it. It consists of 4 parallel 8-bit ports, which are programmable as well as addressable as per the requirement. As on-chip crystal, so an on-chip crystal oscillator is integrated in the microcontroller having crystal frequency of 12 MHz. So architecture of 8051 microcontroller looks like this. The following diagram, the system bus consists all the support devices to the CPU. So the system consists of 8-bit data bus, so it consists of a 8-bit data bus, 16-bit address bus, and bus control signals. All other devices like program memory, ports, data memory, serial interface, interrupt controls, timers, and CPU are all integrated together through the system bus. So in this diagram, you can see the timers, serial ports, and the address data. Address data was present here, and RAM, which is on-chip ROM for program code, bus control, oscillator, CPU, and interrupt controls. So interrupt controls are external interrupts are here in T0 and in T1. Okay. So the other like here is TXD and RxD counter inputs were present here at the timers T1 and T0. So this was the pin diagram of 8051 microcontroller looks. Okay. There were 1
Excuse me,
to
sir.
40
Hello.
pins was present. Yeah. Tell me.
Sir, screen sharing is not started, sir. Anything is not visible.
Okay. Is it visible now?
Yes, sir.
Okay. So this is the architecture of 8051 microcontroller. Okay. Here's the serial ports. Here are the timers and on-chip RAM. This is for input and output ports, bus control, on-chip RAM, and interrupts control, CPU, and oscillator. Okay. Next. Here was the 1 to 40 pins. In 8051 microcontroller consists of mainly 40 pins. So these were those. So 1 to 8 pins, the first 8 pins. These pins are known as ports. So this port doesn't this port doesn't serve any other functions. It is internally pulled up bidirectional input output ports. These are the input and output ports. Okay. Next, Pin number 9 was the reset. 10 to 17. Pins 10 to 17. These pins are known as port 3. This port serves some functions like interrupts, timers, timer input, control signals, serial communication signals, etc. So next 18 and 19. 18 and 19 are used for interfacing an external crystal to get the system clock. 18 and 19, these were used for system clock. And 20 provides the ground power supply to the circuit also. Okay. Pin 21 to 28 provides, it was a port 2. 21 to 28. Up to here it was the port 2. Okay. Next. Pin 29. This is the PSEN pin, which stands for Program Store Enable. It is used to read signal from the external program memory. Pin 30. Pin 30. This is an EA pin which stands for External Access Input. It is used to enable or disable the external memory interfacing. Pin 31. This is an ALE pin which stands for Address Latch Enable. It is used for demultiplex the address data signal of the port. The pins 32 to 39 are known as port 0. So these are the lower order address and data bus signals are multiplexed using this port. The final pin was pin 40. This is used to provide power supply to the circuit. So 8051 microcontroller have 4 input output ports, each of 8 bit, which can be configured as input or output. Hence, 32 pins allow the microcontroller to be connected with the peripheral devices. Okay. So the pin configuration. So the pin can be configured as 1 for input, 0 for output. Okay. According to the logic states, these have been generated. 1 is for input and 0 will be the output. So all the circuits within the microcontroller must be connected to one of its pins except P0, P0 port, because it does not have pull-up resistors built in. Input pin. Logic 1 is applied to a bit of the P resistor. The output FE transistor is turned off and the other pin remains connected to the power supply voltage or over a pull-up resistor of high resistance. Port 0. Port 0 or P0 port is characterized by two functions. When the external memory is used, then the lower address byte is applied on it. Else, all bits of this port are configured as input or output. When P0 port is configured as an output, then other ports consisting of pins with built-in pull-up resistor connected by its N to 5-volt power supply. The pins of the port have this resistor left out. Next, Arduino. So Arduino is a prototype platform based on an easy-to-use hardware or software. It consists of circuit board which can be programmed in a ready-made software called Arduino IDE. IDE stands for Integrated Development Environment, which is used to read, write, and upload the computer code to the physical board. The features of Arduino. Arduino boards are able to read analog or digital input signals from different sensors and turn it into an output such as activating a motor, turning LED on or off, connected to the cloud, or many other actions. You can control your board functions by sending a set of instructions to the microcontroller on the board via Arduino IDE. Unlike most previous programmable circuit boards, Arduino does not need an extra piece of hardware. In order to load a new board onto the board, you can simply use a USB cable. Additionally, the Arduino IDE uses a simplified version of C++, making it easier to learn program. Finally, Arduino provides a standard form factor that breaks the functions of microcontroller into a more accessible package. The board types. Various kinds of Arduino boards are available depending on different microcontrollers used. However, all Arduino boards have one thing in common. They are programmed through Arduino IDE. The differences are based on the number of inputs and outputs, the number of sensors, LEDs, and buttons you can use on a single board, speed, operating, voltage, form factor, etc. Some boards are designed to be embedded and have no programming interface, which you would need to buy guarantee separately. Some can run directly from a 3.7-volt battery. Others need at least 5 volts. These were the list of different Arduino boards available. So Arduino boards based on Atmega 32U4 microcontrollers for here, and followed by Arduino boards based on Atmega 2560 microcontrollers, and that was followed by Arduino boards based on At91 SAM3X80 microcontroller. So next one was Arduino Uno. The Arduino Uno is the standard board of Arduino. Here Uno means one in Italian. So it was named as Uno to label the first release of Arduino software. It was also the first USB board released by Arduino. It is considered as the powerful board used in various projects. Arduino.cc developed the Arduino Uno board. Arduino Uno is based on an Atmega 328P microcontroller. It is easy to use compared to the other boards, such as Arduino Mega board, etc. The board consists of digital and analog input-output pins, shields, and other circuits. The Arduino Uno includes 6 analog inputs, 14 digital pins, and a USB controller, a power jack, and an in-circuit serial program. It is programmed based on IDE, which stands for Integrated Development Environment. It can run on both online and offline platforms. The IDE is common to all available boards. So the components present in an Arduino Uno boards are shown here. So this was the power LED indicator. This is the microcontroller Atmega 328. Here are the two. Here are the analog pins A0 to A5. 6 analog pins. This was the in and this was the ground. Reset button. 3.3 volt power supply. Here is the power button. Voltage regulator. Crystal oscillator. And USB reset button. Okay. Next. Components of Arduino Uno board. So the first thing present in our Arduino Uno board was the microcontroller. The microcontroller used in Arduino Uno board was Atmega 328. It is a single chip microcontroller of the Atmel family. The processor code inside it is 8-bit. It combines memory, analog to digital converter, SPI serial ports, input output lines, registers, timer, external and internal interrupts, and an oscillator. So ICSP pin. The in-circuit serial programming pin allows the user to program using the firmware of the Arduino board. Power LED indicator. The on status of the LED shows the power is activated. When the power is off, the LED will be not light up. Digital input-output pins. The digital pins have the value high or low. The pins numbered from D0 to D13 are digital pins. TX and RX LEDs. The successful flow of data is represented by the lighting of these LEDs. AREF, the analog reference. The analog reference pin is used to feed a reference voltage of the Arduino Uno board from the external power supply. Reset button. It is used to add a reset button to the connection. USB. It allows the board to connect the computer. It is essential for the programming of the Arduino Uno board. Crystal oscillator. The crystal oscillator has a frequency of Reset button. It is used to add a reset button to the connection. USB. It allows the board to connect to the computer. It is essential for programming of Arduino Uno board. Crystal oscillator. The crystal oscillator has a frequency of 16 megahertz, which makes the Arduino Uno a powerful board. Voltage regulator. The voltage regulator converts the input voltage to 5 watts. GND. Ground pins. The ground pin acts as a pin with zero voltage. VIN. It is the input voltage. Voltage in VN stands for. Analog pins. The pins numbered from A0 to A5 are analog pins. The function of analog pins is to read the analog sensor used in the connection. It can also act as general purpose input-output pins. Next, memory. The memory structure is shown in the below image. Here you can see the memory structure of the Arduino Uno board. So this is the memory structure of an Arduino Uno board. The Arduino Uno board consists of flash memory of 32 KB and pre-installed flash, which has a bootloader of 0.5 KB. So SRAM is 2 KB and EEPROM was 1 KB. So the pre-installed flash has a bootloader which takes memory of 0.5 KB. Here SRAM stands for static random access memory and EEROM stands for electrical erasable program read-only memory. So technical specifications of Arduino Uno. The technical specifications of Arduino Uno are listed below. The 20 input-output pins present on the Uno board. The 20 pins including 6 PWM pins, 6 analog pins, 8 digital input-output pins. PWM pins are pulse width modulation capable pins. The crystal oscillator present in Uno board comes with a frequency of 16 megahertz. It also has Arduino integrated Wi-Fi module. Such Arduino Uno board is based on integrated Wi-Fi ESP8266 module and 8 328P microcontroller. The input voltage of the Uno board varies from 7 watts to 20 watts. Arduino Uno automatically draws power from the external power supply. It can also draw power from the USB. Arduino Uno pinout. The Arduino Uno is standard board of Arduino which is based on an 8 328P microcontroller. It is easier to use than other types of Arduino boards. The Arduino Uno board with the specifications of pin is shown. SDA. It stands for serial data. It is a line used by the slave and master to send and receive data. It is called as a data line, while SCL is called as a clock line. SCL stands for serial clock. It is defined as the line that carries the clock data. It is used to synchronize the transfer of data between two devices. The serial clock is generated by the device and it is called as master. SPI. It stands for Serial Peripheral Interface. It is popularly used by the microcontrollers to communicate with one or more peripheral quick devices. It uses conductors of the data receiving and data sending synchronization and device selection. MOSI. It stands for Master Output Slave Input. The MOSI and SCK are driven by the master. SS. It stands for Slave Select. It is the slave select line which is used by the master. It acts as the enable line. I2C. It is the two-wire serial communication protocol. It stands for inter-integrated circuits. The I2C is a serial communication protocol that uses SCL and SGA. SCL stands for serial clock and SGA stands for serial data. These two to receive and send data between two devices. 3.3 volts and 5 volts are the operating voltages of the board. Next one was the Arduino Nano. Arduino Nano is small Arduino board based on Atmega 328P or Atmega 628 microcontroller. The connectivity is the same as the Arduino Uno board. The Nano board is defined as a suitable, small, consistent, and flexible microcontroller board. It is the small in size compared to the Uno board. The Arduino Nano is organized using the Arduino IDE, which can run on various platforms. Here IDE stands for Integrated Development Environment. The devices required to start our project using Arduino Nano board are Arduino IDE and Mini USB. The Arduino IDE software must be installed on our respective laptop or desktop. The Mini USB transfers the code from the Arduino computer to the Arduino Nano board. Drawback present in Arduino Nano board was the DC power jack is absent in the Nano. Thus, we cannot use the battery to apply an external power supply. So this is how a Nano board looks like. Why is Arduino Nano used? Using the constant voltage, the Arduino Nano is used to produce a clock of a precise frequency. The differences between Arduino Uno and Arduino Nano boards are the Arduino Nano has a compact size and mini USB cable than the Arduino Uno. We can use Nano instead of Uno because both operate on the microcontroller Atmega 328P. The Arduino Uno is also easily available than Nano. It is considered as the standard board available in the market, which is easy for use for the starters or beginners. The Nano is available in PDIP, plastic dual inline package, while Arduino Uno is available in PQFP, plastic quad flat pack. The Arduino Uno includes 6 analog pin inputs, 14 digital pins, a USB control connector, a power jack, and an ICSP. ICSP stands for In-Circuit Serial Programming Header. The Arduino Nano includes an I/O pins set of 14 digital pins and 8 analog pins. It also includes 6 power pins and 2 reset pins. Memory. The memory in Arduino Nano is shown as in the below image. The pre-installed flash has a bootloader which takes the memory of 2 KB. The technical specifications of Arduino Nano board. So the voltage of Arduino Nano varies from 5 volts to 12 volts. The total pins in Nano are 22 input-output pins. There are 14 digital pins and 8 analog pins. There are 6 PWM pins among 14 digital pins. The 6 PWM pins in Arduino Nano are used to convert the digital signals into the analog signals. The conversion takes place by varying the width of pulse. The crystal oscillator present in Arduino Nano comes with a frequency of 16 MHz. The Arduino Nano is used in various applications such as robotics, control system, instrumentation, automations, and embedded system. The projects created using Arduino Nano are QR code scanner, DIV, Arduino pedometer, etc. We can also connect Arduino Nano to the Wi-Fi. The functionality of Nano is similar to the Arduino Uno. The flexibility and eco-friendly nature of Nano make it a unique choice to create electronic devices and projects with compact size. Arduino Nano pinout. The Arduino Nano is a small Arduino board based on 8MEGA328P or 8MEGA628 microcontroller. The Nano board is defined as a small and flexible micro board. So here you can see the board, the Nano board with its pin specifications. pin descriptions of the Arduino Uno board. So here we use the 8 mega 328 pin microcontroller. And the pins RxD and TXD pins are used for serial communication. The TXD is used for transmitting the data and RxD is used for receiving the data. It also represents the successful flow of data from computer to the board. Mini USB. The mini USB is smaller than the standard USB, but thick than the micro USB. It allows the board to connect to the computer. It is essential for the programming for Arduino Nano board. It is We usually plug the USB cable in the mini USB jack to load the sketch to the board. SMD crystal. The surface mount crystals have better stability than other crystals. The device can be easily soldered on the board. The SMD crystal used in the Arduino Nano is of 16 megahertz. RST. It is used to add a reset button to the connection. Power indicator. It indicates the status of the battery. It can also show the voltage of the battery on the LCD display connected to the Arduino board. Digital pins. There are 14 digital input-output pins. The 6 pins from the set of digital pins are PW. Pins numbered D3, D5, D6, D9, D10, and D11. The digital pins have the value either high or low. Analog pins. There are 8 analog pins numbered from A0 to A7. The function of analog pins is to read the value of analog sensor used in the connection. It also acts as GPIO, which stands for General Purpose Input Output. Analog reference. The analog reference pin acts as a reference voltage to feed the Arduino from an external power supply voltage. Voltage in. It is defined as the input voltage, which is applied to the Arduino board when it is using an external power source. The 3V3. The 3V3 pins works as the output regulated voltage of 3.3 volts. 5 volts. The 5 volt pin works as the output regulated voltage of the 5 watts. The power source of 5 watts of the Arduino Nano board are USB connected DC power jack and the pin. The power can supply to the board from either of the above specified sources. Arduino Mega. The Arduino Mega is based on ATmega 2560 microcontroller. The ATmega 2560 is an 8-bit microcontroller. You need a simple USB cable to connect to the computer and the AC to DC adapter or battery to get started with it. The Arduino Mega is organized using the Arduino IDE, which can run on various platforms. Here IDE stands for Integrated Development Environment. The functioning of the Arduino Mega is similar to the other Arduino boards. We need not require extra components for its working. The ATmega 2560 microcontroller is consistent with most of the shields of Arduino Uno. So this is how an Arduino Mega board looks like. Guys, is anyone having any doubts regarding up to these topics? Guys, please do respond. ఎవరికైనా ఏమైనా డౌట్స్ ఉన్నాయా? ఎలాంటి డౌట్స్ లేకపోతే హ్యాండ్స్ రేజ్ చేయండి. వాట్ అబౌట్ అదర్స్? క్లాస్ అర్థమవుతుంది అసలు? జస్ట్ క్లాస్ అర్థమవుతుందా అవ్వట్లేదా? ఎవరికైనా అర్థం కాకపోతే హ్యాండ్స్ రేజ్ చేయండి. So why we use Arduino Mega? The advantage of using Arduino Mega board over other boards is that it gives the advantage of working with more memory space. So it has higher processing power, which can help us to work with the number of sensors at a time. What is difference between Uno and Mega? The Uno is based on 8 Mega 328 microcontroller, and the Mega is based on 8 Mega 2560 microcontroller. Arduino Mega requires more RAM space than the Arduino Uno. The greater standard RAM space, the greater static RAM space, the more space would the Arduino have to manipulate and create a variable when it turns. The Arduino Uno includes 6 analog pin inputs, 14 digital pins, a USB connector, a power jack, and an in-circuit serial programming header. The Arduino Mega includes 54 input-output digital pins and 16 analog input-output pins, ICSP header, a reset button, 4 UART ports. UART stands for Universal Asynchronous Receiver Transmitter, USB connection, and a power jack. Memory. The memory structure is shown in the below diagram. The pre-installed flash has a bootloader which takes the memory of 8 KB. Here, static RAM and electronic erasable programming read-only memory are present. Technical specifications of Arduino Mega. So, the Arduino Mega board consists of 54 input-output digital pins and 16 analog input pins present on the Mega board. The 15 pins from the 54 digital output pins are PWM output pins. The PWM pins are pulse width modulation capable pins. The input voltage of the Mega board varies from 7 watts to 12 watts. The functionality of Mega is similar to the Arduino Uno. The operating voltage of the Arduino Mega is 5 volts. The Mega board is considered superior in terms of static RAM memory space. It is well suited for most of the Arduino shields. The bootloader is used to eliminate the exterior burner utilization. It is generally used to create complex projects due to its structure. The projects that use Arduino Mega board are IoT applications, 3D printers, temperature sensing, monitoring of real-time applications, etc. So this is how a Arduino Mega board looks like. The description of Arduino board. So in Arduino Mega, the microcontroller present was 8MEGA2560. The 8MEGA2560 is a CMOS, complementary metal oxide semiconductor. It was a low-powered 8-bit microcontroller. The 8MEGA2560 is based on AVR RISC architecture. Here AVR stands for Audio Video Recorder and RISC stands for Reduced Instruction Set Computing. It is used for the boards that require more memory, sketch, and input-output lines. It is recommended for complex projects such as robotics, etc. GND. Ground pins. The ground pins are used to ground the circuit. USB port. It allows the board to connect to the computer. It is essential for the programming of the Arduino Mega board. We usually plug the USB cable in the USB port to load the sketch of the board. UART. It stands for the Universal Asynchronous Receiver and Transmitter. It, it permits the Arduino to communicate with several devices. Power jack. The power jack is used to supply the power to the board. The adapter is plugged into the power jack of the Arduino Mega board. ISCP header. The program of firmware with the advanced functionalities is received by the microcontroller with the help of ICSP header. ICSP stands for In-Circuit Serial Programming. The ICSP header consists of 6 pins. Here it shows the top view of the ICSP header. I2C. It is a two-way serial communication protocol. It stands for Inter-Integrated Circuits. The I2C is a serial communication protocol that uses SCL and SDA to receive and send data between two devices. The SCL is a clock line, while SDA is a data line. SCL stands for serial clock, and SDA stands for serial data. Analog pins. There are total 16 analog pins from A0 to A15. The function of analog pins is to read an analog sensor used in the connection. It can also act as GPIO, general purpose input output pins. Digital pins. There are 54 digital input output pins from pin numbered 0 to 53. The 15 pins from the digital input output are PWM. PWM stands for pulse width modulation pins. These were numbered from D2 to D13 and D44 to D46. The digital pins have the value of either high or low, SPI and SCK. It stands for serial peripheral interface. It is popularly used by the microcontrollers to communicate with one or more peripheral devices quickly. The SCK stands for the clock, serial clock. In slave, it works as the input of the clock generator. In master, it works as the output clock. SPI can even have various devices on the bus. MISO. It stands for master in or slave output. The slave line is the slave line in MISO is used to send data to the master. MOSI. It stands for master output slave input. The MOSI line Arduino carries the data from Arduino to the control devices of SPI. The slave line in MOSI is used to send data to its peripherals. SS. It stands for slave select. It is the slave select line, which is used by the master. It acts as the enable line. The MISO and MOSI and SS supports SPI communication. The multiple SPI devices in Arduino are able to share same SS, MOSI, and MISO lines. IOREF. It stands for input-output voltage reference. It allows the shields to check the operating voltage 3.3 volts or 5 volts of the board. The shields are connected to the Arduino board. The microcontroller operates with reference voltage provided by the IOREF. 5 watts. The 5-watt pin works as the input voltage regulator of 5 watts. 3V3. The 3V3 pin works as the output regulated voltage of 3.3 watts, RX and TX. The successful flow of data is represented by lighting of the TX and RX LED. Green. It is defined as the input voltage which is applied to the Arduino board when it is using an external power source. Guys, up to today's class, is there any doubts? Raise your hand. If the class is clear to you all, please raise your hands also. Till today, we have discussed what is meant by microcontroller, what is meant by microprocessor, the architectures of microprocessor and microcontroller, and different types of microcontrollers. We have discussed two types of microcontrollers today, the Arduino family and 8051 microcontroller. Regarding these topics, is anyone having any doubts?